Hello everyone, welcome to MH Math Academy's KCET Crash Course 2025. In this lecture, we shall start with the next concept, that is limits and continuity. Uh, it is going to be a very important concept as far as the KCET is concerned, because you are going to get around 2 to 3 questions, okay, 2 to 3 questions from this chapter alone. Okay, so I request that you concentrate throughout the lecture thoroughly, and make sure you go through each and every problem that I solve, and also the additional previous year questions that you get, okay, on this particular chapter. Okay, and also as far as the theory is concerned, I will be revising the required theory part along with the questions itself. So I request that you thoroughly listen to me throughout the lecture without getting distracted. Okay, so without any further delay, let us now take up the first question, which was asked in 2023. Okay, the question says, if the function is f of x equal to 1 by x plus 2, then the point of discontinuity of the composite function y equal to f of x is. Okay, so this is what is being asked. If you look at the points of discontinuity and about the definition of continuous function, a function f of x is said to be continuous at x equal to c when the left hand limit and right hand limit and the value of the function f at c are you know are all three equal. So at x equal to c, the left hand limit, right hand limit, and the value of the function are equal. So when this is satisfied, then we say that the function is continuous. But before even saying that the function is continuous, the very fundamental concept is the function must be defined in order to be eligible for the checking of continuity. For example, if I take, let's say, the function 1 by x, and if I ask you to check the continuity at x equal to 0, you will say that at x equal to 0 the function 1 by x is not even defined. So therefore, how can we even check the continuity of this function? It is impossible. So therefore, for a function to be continuous, then the very first criteria for that function to be defined. So it has to be defined, and then only we can check the continuity of the function. So what we can do is, in this case, we will first find out y is equal to f of x and see whether the function is defined for all the real values or not. So we will take up y equal to f of x, which is equal to f of, what is f of x? 1 by x plus 2. Okay, so this is going to be, now what is f of something? It is 1 by something plus 2, right? What f of x is 1 by x plus 2, so f of something would be 1 by something plus 2. What is that something? It is 1 by x plus 2, right? So if you take the LCM, it is going to be x plus 2 divided by 1 plus 2x plus 2 2s are 4. So it is going to be what? X plus 2 divided by 2x plus 5, right? So therefore y is equal to what? X plus 2 divided by 2x plus 5. As you can see, it is of the form p of x divided by q of x, where p and q are the polynomial functions. The p is going to be x plus 2, which is a linear function, and 2x plus 5 is going to be again a linear function. So therefore it is a rational function as a whole. Therefore it is everywhere continuous except at the points when the denominator is 0. Can the denominator be 0 here? The denominator can be 0 at which point? If I equate 2x plus 5 to 0, it is going to be minus 5 by 2. The value of x is going to be minus 5 by 2. So I can say that this function, that is y equal to x plus 2 divided by 2x plus 5, is discontinuous when 2x plus 5 is equal to 0. So therefore it is discontinuous when x is minus 5 by 2. Therefore it is going to be the option 2. Okay, so at minus 5 by 2, this function is going to be discontinuous. Okay, so let us go to the next question without any delay. The question says, the function f of x equal to cot x is discontinuous on every point of the set. Okay, so the function f of x equal to cot x. Look, just now we have solved a problem which was asked in 2023. Okay, in this the denominator should not be 0. That was the criteria. Again, if you look at this function, that is f of x is equal to cot x. F of x, can I write this down as cos x divided by sin x? Yes. So our criteria again here is sin x should not be equal to 0. Sin x should not be equal to 0. If sin x is equal to 0, then the function is going to be discontinuous. So sin x becomes 0 where? The sin x becomes 0 at sin 0, sin pi, right? Sin 2 pi, sin 3 pi. Okay, so at any sin n pi, the sign is going to even sign of minus pi, right? At all these points the sign is going to be 0, so therefore the sign is going to, I mean this uh, sign is going to be 0 at sin n pi for some integer n, right? When sin becomes 0, this cos x by sin x is not defined. That means f of x is not defined. So therefore, since f of x is not defined at these particular points, we can say that f of x is discontinuous in all those x which is equal to what? N pi where n belongs to z. So therefore it must be the option B, that is option 2. At n pi it is going to be 0, okay, and not defined, so therefore it is going to be discontinuous. Okay, coming to the next question, that is if limit of sine 2x minus sorry sine 2 plus x minus sine 2 minus x divided by x as x tends to 0 is equal to a cos b, then the values of a and b respectively are. You can see this is the third question that we are getting in 2023. The first two, the questions that we discussed were based on continuity, and this question here is based on the evaluation of the limit. Okay, so now if I take this one, that is limit of sine 2x, sorry 2 plus x minus sine of 2 minus x whole divided by x as x tends to 0. Okay, if I take this particular function and if I substitute the value 0 in the place of x, I am going to get sine 2 minus sine 2 divided by 0, which is equal to 0 by 0, which is indeterminate form. Okay, so what is the process of evaluating the limits? We will first substitute the value of x. If it is 0 by 0 or infinity by infinity or any of the indeterminate forms, then we use either simplification or L'Hospital rule or something to evaluate, to simplify the function, or to take out those particular what do you say, factors of the function which are making the function 0. So if we take out those factors, then the function is automatically going to be non-zero, so therefore we will be getting the determinate forms of the limit. So what we will do in this case is we will use a rule known as L'Hospital's rule. It is also called as the L'Hopital's rule. Okay, it depends on you how you pronounce it. So I'm going to just call it as the L'Hopital's rule. What will the L'Hopital's rule say? It says that if f of x by g of x, the limit of this as x tends to c, is giving you 0 by 0 or infinity by infinity, then what does it say is you differentiate it and evaluate the limit there. The differentiating numerator and denominator separately, not by using the u by v rule. Okay, so f dash by g dash as x tends to c. If this is again giving you 0 by 0 or infinity by infinity, you differentiate it again, f double dash by g double dash. So you can keep on doing this. That is what the L'Hopital's rule says. Okay, so I am going to use the L'Hopital's rule to evaluate this limit. If in case I don't get it, then we'll see. Okay, see, I had told you in the previous lecture also, don't have to be worried about the answer or the solution of the question. At the most, uh, what can happen is we will get the wrong answer, or we don't get the answer, we get stuck. So apart from that, nothing is going to happen. So we'll just see what's going to be the solution of this. So the limit of sine 2 plus x minus sine of 2 minus x whole divided by x as x tends to 0 is equal to, if I take it in this way, what is sine of 2 plus x? It is cosine of 2 plus x minus sine of 2 minus x is cosine of 2 minus x. The derivative of 2 minus x is minus 1, so therefore minus into minus would be plus, divided by the derivative of x is 1. So I have applied the L'Hopital's rule. If I substitute x equal to 0, what am I going to get? I'll get cos 2 plus 0 is cos 2 plus again cos 2 divided by 1 is just, it doesn't really matter. Cos 2 plus cos 2 is 2 cos 2. Okay, which is not equal, which is not equal to 0 by 0 or infinity by infinity, of course. So therefore what can I say is, the values of a and b respectively are, what are these going to be? If I compare this with a cos b, then the value of a is 2 and the value of b is also 2. So therefore it must be the second option, that is 2 comma 2. Fine. So this is what we have. So this was about the questions in the year 2023. We will now go to the questions which were asked in the year 2022. Okay, what does it say? The value of the limit of root 3 plus y cube minus root 3 divided by y cube. Okay, so again, if possible, we'll see what is going to be the value of the limit and then decide what has to be done. Root 3 plus y cube minus root 3 divided by y cube as y tends to 0, right? So this is going to be equal to the limit of, okay, if I substitute y equal to 0, it is going to be root 3 minus root 3 divided by 0, right? I think that is going to be equal to 0 by 0, right? That is going to be equal to 0 by 0, which is an indeterminate form, right? So if I have to use the L'Hopital's rule, it is going to be limit of root 3 plus y cube minus root 3 divided by y cube as y tends to 0. So this is equal to the limit of, if I differentiate this root 3 plus y cube, it is going to be 1 by 2 root x, that is 1 by 2 root 3 plus y cube, right? Into the derivative of 3y cube is going to be 3y square, right? Minus the derivative of root 3 is 0 divided by the derivative of y cube is 3y square, right? This 0 is obviously gone, 3y square and 3y square will get cancelled out as y tends to 0. So if I put y equal to 0, I am going to get 1 by 2 root 3 plus 0, which is equal to 1 by 2 root 3. So therefore it must be which option? It must be the option A. It is 1 by 2 root 3. If in case you are not very well versed with the differentiation and if you want to use any property, then also you can solve it. There is a property that says limit of x raised to n minus a raised to n divided by x minus a as x tends to a is equal to n into a raised to n minus 1. Okay, so if you look at this, the limit of, can I write this down as 3 plus y cube whole raised to 1 by 2 minus 3 raised to 1 by 2 divided by, I will write this y cube as 3 plus y cube minus 3. So is it of the form x cube minus, x raised to n minus a raised to n divided by x minus a? Yes. As x tends to a is what I need. X is 3 plus y cube tends to 3. Okay, so 3 will get cancelled out. I'll get y cube tends to 0, which is y tends to 0. Y tends to 0 is the limit that they have given, right? So therefore what the limit that they have given is absolutely fine. This is equivalent to the limit y tends to 0. This is very much equivalent to the limit y tends to 0. So it is equal to n into x raised to, what is x? X is uh, sorry, n into a raised to, what is a? 3 raised to n minus 1. N is how much? 1 by 2 minus 1, which is going to be 1 by 2, 3 raised to minus 1 by 2. So this is going to be 1 by 2, 3 raised to 1 by 2. This is 1 by 2 times 3 raised to 1 by 2 is root 3. So it is going to be 1 by 2 root 3. So in any of these methods, you are going to get the same answer. Okay, of course, the answer shouldn't even change. Fine. Let us go to the next question now, again, which was asked in 2022. Okay, the question says, if f of x is equal to so and so, the quadratic equation whose roots are. Okay, well, so first we will see what is the definition of the function. How is the function defined? Okay, between this is 0, let's say this is 2, and let's say this is 3. Between 0 and 2, I mean when x is between 0 and 2, the function is x square minus 1. When x is between 2 and 3, including 2 and 3, okay, including 2 and 3, sorry, not including 3, no, excluding 3, right, excluding 3, the function is what? The function is going to be 2x plus 3. All right, so now they need the limit of f of x as x tends to 2 minus, okay, this is equal to, let's say, the limit of, see, 2 minus is approaching 2 towards, I mean from the left hand side, so it is f of x is going to be x square minus 1 as x tends to 2, which is equal to 4 minus 1, that is 3, right? I will call this as I or else I leave it like this. I will take this up a bit later. The next one is going to be what? The next one is going to be limit of f of x as x tends to 2 plus, which is equal to the limit of 2x plus 3, okay, as extends to 2, because we are approaching 2 from right hand side, so it is going to be 2 2s are 4 plus 3, which is going to be 7. Okay, so this is what we have, and what they are saying is this limit and this limit have to be the roots of a quadratic equation. So let us call this as alpha, say, okay, and this as beta. Okay, so if we call one of the roots as alpha and the other one as beta, then we have the quadratic equation, which is x square plus alpha, sorry, minus alpha plus beta times x plus alpha beta is equal to 0. So this will give us what? This will give us x square minus alpha plus beta is going to be 7 plus 3, that is 10x, plus alpha beta is going to be 21, which is equal to 0. So if you check, it must be the option 2, that is x square minus 10x plus 21 is equal to 0. Okay, so this is what you have. Coming to the next question, the next question says, if f of x is equal to the determinant of so and so, then the value of limit of f of x as extends to pi is. Okay, so if you expand the determinant here, what you are going to get is f of x is equal to, or let's say f of x is equal to cos x into, I'll get 2 2s are 4 cos square x minus 1 3s are 3. Okay, this is plus, this is minus, this is plus, minus 1 into 0 minus 0, of course plus 0 into anything is going to be 0, so it is 4 cos cube x minus 3 cos x, okay, and this is anyways going to be 0. 4 cos cube x minus 3 cos x is, of course, it is cos 3x, right? So therefore your f of x that is given here is just cos 3x, right? Since this is just cos 3x, they are asking the limit of f of x as extends to pi. So f of, I mean, the limit of f of x as extends to pi is going to be the limit of what? Cos of 3 pi as extends to pi. This is equal to, what is cos of 3 pi? Remember, cos 0, cos pi, cos 2 pi, cos 3 pi, and then cos 4 pi, and then cos 5 pi, okay, like this. See, the even multiples of pi within, when they are within cos, will give you 1, and odd multiples of pi when they are within cos will give you minus 1. So therefore cos 3 pi is going to be minus 1, so therefore it is going to be the option A, that is equal to minus 1. Okay, that was a very easy question. Now The next question says, consider the following statements. Statement 1 says limit of ax square plus bx plus c divided by cx square plus bx plus a as extends to 1 is equal to, if I put x equal to 1, I am going to get a plus b plus c divided by c plus b plus a, which will definitely get cancelled out. I am going to get 1. So they have given that, see, the statement ends here. Okay, this is the statement 1 and this is the statement 2. Fine, ends here. Okay, so it is equal to 1, so therefore statement 1 is true. 1 is true. Okay, and coming to the statement 2, the statement 2 says limit of 1 by x plus 1 by 2 divided by x plus 2 as extends to minus 2, right? If I put x equal to minus 2, what am I going to get? I am going to get minus 1 by 2 plus 1 by 2 divided by minus 2 plus 2, which is equal to 0 by 0. This and this will get cancelled out, this and this will get cancelled out. 0 by 0, which is indeterminate form. So what should I do with this now? I will try to apply L'Hospital's rule. So it is equal to minus 1 by x square. It is 0 divided by 1 as extends to minus 2, which is equal to minus 1 by minus 2 whole square is 4, and then divide by 1, so it is going to be minus 1 by 4. But what they have given here is 1 by 4, which is wrong. So therefore statement 1 is true and statement 2 is false. So only statement 2 is true, it is wrong. Only statement 1 is true, yes, it is correct. Both statements 1 and 2 are true, wrong. Both statements are false, again wrong, because statement 1 is absolutely true. Okay, so this is what you have. The next question says, okay, the right and left hand limit of the function f of x equal to so and so are respectively. Okay, so what do you mean by left and right hand limits? Look, okay, what does the function say is, let us say this is x equal to 0, minus infinity, plus infinity. Here x is less than 0 and here x is greater than 0. So when I say x is less than 0, of course x is not equal to 0. Here also x is not equal to 0, right? When x is not equal to 0, the function is defined by e raised to 1 by x minus 1 divided by e raised to 1 by x plus 1. When x is greater than 0, the function is defined by e raised to 1 by x minus 1 divided by e raised to 1 by x plus 1. When x is equal to 0, the function is defined by 0. Okay, so this is what is given. Now, the left hand limit, if I have to evaluate, the LHL is equal to limit of f of x as extends to 0 minus, which is going to be the limit of e raised to what? 1 by x minus 1 by e raised to 1 by x plus 1 as extends to 0 minus. Since we are approaching 0 from the negative side, okay, I mean, if I have to actually take it up this way, it is going to get a bit difficult. But if you have a very good knowledge, then we can directly do it. Since we are approaching x from, I mean, x equal to 0 from the left hand side, this one is going to be e raised to minus 1 by 0 minus 1 divided by e raised to again minus 1 by 0 plus 1. So it is going to be e raised to 1 by 0 is what? Infinity. So e raised to minus infinity is going to be 1 by e raised to infinity, which is 1 by infinity, so therefore 0. So it is going to be minus 1 divided by, this is also 0, so it is going to be plus 1, which is equal to 1. Okay, so if you don't quite get it, so what I will do is I will take up the conventional notation for the limits and then I will explain it to you. Just give me a moment. Okay, look, if I take up the left hand limit, it is going to be the limit of f of x as extends to 0 minus, which is equal to the limit of 0 minus h as h tends to 0, right? So it is going to be limit of 0 minus h is what? Minus h as h tends to 0, right? So this will be equal to what? The limit of what is f of minus h? It is going to be e raised to minus 1 by h, right? Divided, sorry, minus 1 divided by e raised to minus 1 by h plus 1 as h tends to 0, which is equal to, as I said previously, this and this are going to be 0. So I'll get minus 1 by 1, which is equal to minus 1. Okay, and mind you, why is it 0? Because it is going to be e raised to minus infinity, which is 1 by e raised to infinity, which is 1 by infinity, which is 0. Okay, so same is the case with this. Fine. If I take the right hand limit, okay, if you look at the options, option 1 says the left hand limit is towards right, right? So therefore left hand limit, either fourth or third can be the right answers. Let's see. We'll also find out the right hand limit. Right hand limit is going to be what? Limit of f of x as x tends to 0 plus, right? So this is equal to the limit of 0 plus h, f of 0 plus h as h tends to 0, which is equal to the limit of, we will see, we should try to avoid infinity. Okay, the limit of e raised to 1 by h plus 1 divided by e raised to 1 by h, I think this is minus, plus 1 as h tends to 0. Okay, so just a minute. Fine. So this will be equal to, what I'll do is I'll divide every term by e raised to 1 by h. So I'm going to get 1 minus 1, I mean 1 by e raised to 1 by h divided by 1 plus 1 by e raised to 1 by h as h tends to 0. So this is going to be infinity, this is going to be infinity. 1 by infinity is 0. So this term is 0 and this term is also 0. So you are going to get what? 1 by 1, which is equal to 1. So therefore the left hand limit is minus 1 and the right hand limit is plus 1. So left hand limit is minus 1 and right hand limit is plus 1. So it is wrong. This must be the correct answer. So the option 3 is the right answer. Fine. So let us now go to the next question. The next question says, if f of x is equal to 1 minus cos kx by x sin x when x is not equal to 0, so answer is continuous at x equal to 0, then the value of k is, okay. When do we say that a function, see, it is given that the function is continuous, right? Just shift it a bit. Okay, see what is given, f is continuous at x equal to 0. So it immediately implies what? The limit of f of x as x tends to 0 exists and it is equal to f of 0, right? Now this will tell us, this implies the limit of, what is f of x? F of x is 1 minus kx divided, sorry, oh, I'm extremely sorry, 1 minus cosine kx divided by x sin x, okay, as x tends to 0 is equal to, what is f of 0? It is 1 by 2, right? That is what they have given. Now how will you write down this 1 minus kx? Either you can use the L'Hospital's rule or you can, simplify and try to get the answer. But in my suggestion, it is better that you simplify it. Okay, we know that 1 minus cos 2x is 2 sine square x, right? 2 sine square x. So whatever angle you have here, it is going to be the half of it. So therefore, what I can do is 1 minus cos kx can be written as 2 sine square k by 2x, right? So I can write it this way. I hope you are understanding what I am doing. Fine. So what I will do now is I am going to write this down as the limit of, okay, uh, or else shall we do it the, okay, fine, I'll first use this and then we'll see if we can use the L'Hospital's rule. Okay, so it is going to be 2 sine square k by 2x, okay, whole divided by x sine x, okay, is equal to 1 by 2, the limit of this as x tends to 0. Okay, now you see, I will see for this sin x, I will divide it by x and I will multiply it with x. Why? Because sin x by x as x tends to 0 is going to be 1. Okay, so this is going to be 1. Fine. And I got x into x, which is x square here. So in the next step, what I'm going to get is the limit of 2 sine square k by 2x divided by x square. Okay, so now you see this, I will write down this sine square k by 2x as sine k by 2x sine k by 2x. Okay, and I'll write down this x square as x into x. Okay, now what I'll do is I will write down, I will multiply this with k by 2 and I'll divide this by k by 2. Again I'll multiply this with k by 2 and divide it by k by 2. Okay, as x tends to 0. As you can see, the limit of sine k by 2x divided by k by 2x as x tends to 0 is again 1, and this is also 1, which is equal to 1 by 2, right? So what am I finally going to get? I am finally going to get, just a minute, this 2 into, anyways the limit is gone because there is no x term here, so this implies 2 times k by 2 into k by 2 is k square by 4 is equal to 1 by 2. So 2 ones are 2 twos, and then this and this goes, k square equal to 1, so therefore k equal to plus or minus 1. So this is going to be the answer. K is equal to plus or minus 1 is going to be the right answer. But if in case you want to use just a minute. Okay, if in case you want to use the L'Hospital's rule, what we can do is, we can just say the limit of f of x as x tends to 0 is equal to what? 1 by 2. Okay, so this implies the limit of, what is f of x? It is 1 minus cos kx divided by x sin x, right? So 1 minus cos kx divided by x sin x as x tends to 0. Okay, so before applying the L'Hospital's rule, what I'll do is I will divide it by x and multiply it with x. I'll make this one. Okay, so finally I'm going to get 1 minus cos kx divided by x square as x tends to 0. Fine. Now I will apply the L'Hospital's rule. So what am I going to get here? I'm one, the derivative of 1 is 0. Okay, minus cos kx is minus the cos kx, the derivative is minus sin x, so therefore it is going to be minus into minus plus. So what is it going to be? It is going to be sin kx into k divided by the derivative of x square is 2x, right? Now for sin kx I need kx here, so I'll multiply it with k and divide it by k, so it is k into k is k square. This is going to be 1 now, so it is going to be again k square by 2, which is equal to 1 by 2. So k square by 2 is equal to 1 by 2 implies k square is equal to 1, so again k equal to plus or minus 1. So this is what you have. Fine. So again, in both the methods you are going to get the same answer. You can use any one of these. Okay, so let's take up the next question. I'm sorry, I'll move these a bit. Just a minute, some error. Okay, it is resolved now. The next question says limit of so and so is equal to. Okay, if I put the value of x here, if I put tan 0 is 0 divided by root 4 minus 2, which is 0 by 2 minus 2, which is 0 by 0. Okay, so since it is 0 by 0, what I am going to do is I am going to use the L'Hospital's rule, or else I can convert this sin x tan x as sin x by cos x, and then use the sin x by x as x tends to 0 property. Okay, so what I will do now is the limit of tan x, the derivative of tan x is sec square x, okay, divided by the derivative of root of 2x plus 4 is going to be 1 by 2 root x, that is 2 root of 2x plus 4 into the derivative of 2x plus 4 is 2. Okay, so that is what you have. and then the derivative of minus 2 is going to be 0, so it is minus 0. I think that really doesn't matter as x tends to 0. Okay, now I'll try to put x equal to 0. Okay, you can see 2 and 2 will get cancelled out. If I put x equal to 0, sec 0 is 1, so it is going to be 1 divided by 1 by root of 4. So it is going to be root 4, which is plus or minus 2, but in the options you have only the positive 2, so it must be the plus 2, that is option 2. Okay, the answer is also 2, the option is also 2, everything is 2. Okay, fine. The next one says limit of, okay, it is continuous at x equal to 0. So since it is continuous at x equal to 0, what can I say? I can say that the limit of f of x as x tends to 0 is equal to f of 0, right? So this would be the limit of, what is f of x? Sine 3x divided by e raised to 2x minus 1 as x tends to 0 is equal to f of 0 is k minus 2, right? So this will be the limit of, if you put 0, sine 0 is 0 divided by e raised to 0 is 1 minus 1, which is equal to 0 by 0 again, right? So therefore I will differentiate it if possible. So it is 3 cos 3x divided by, what is the derivative of e raised to 2x? It is 2 e raised to 2x minus 0 as x tends to 0 is equal to k minus 2. So this would be, if I put x equal to 0, it is 3 into cos 0 divided by 2 into e raised to 0, which is equal to k minus 2. So this will give me 3 by 2 into cos 0 is 1, e raised to 0 is also 1, equal to k minus 2. So therefore k is equal to 2 plus 3 by 2, which is equal to 2 2s are 4 plus 3 is 7 by 2. So therefore the answer is 7 by 2, that is option C, that is option 3. Fine. So let us take up, I think, the last question, which was asked in 2019. Okay, the question says, just a minute, shift it. Okay, the question says, if the summation of this is equal to x, then the limit of so and so is equal to, fine. Now look, the limit of this one, that is 1 cube plus 2 cube plus 3 cube plus so on up to n cube divided by x square as n tends to infinity is equal to, this is what they have asked. Since the denominator x square is common, I have just written down one denominator for all and I have added the numerator. I think that is of no issue. Now look, what is this x? See, the limit is for n, so I don't have to keep x here. So what is this x? X, the value of x is given, right? So x is equal to what? They have given x is equal to this, that is summation of 2r minus 1, summation of 2r minus 1, where r is from 1 to n. Okay, so this is what is given. Now look, can I write this down as the summation of 2r where r is from 1 to n minus summation of 1 where r is from 1 to n? Yes. So this is going to be 2 times summation of r where r is from 1 to n minus summation of 1 from r equal to 1 to n, right? So this is going to be 2 times, what is the summation of r? The summation of r from r equal to 1 to n is going to be r equal to 1 plus 2 plus 3 so on up to n. So it is the sum of the first n natural numbers, which is n into n plus 1 divided by 2 minus, what is the summation of 1? It is 1 plus 1 plus 1 so on up to how many times? N times. So it is going to be n, right? 2 and 2 would get cancelled out. I will get what? If I take out n common, I am going to get n plus 1 minus 1, okay, which is equal to this, and this will get cancelled out. Okay, is it 2r plus 1 or minus 1? Minus 1. So it is going to be n square. Okay, so I got this sum to be n square. Therefore, what am I going to get? I'm going to get, and moreover, in the numerator I have what? The numerator I have 1 cube plus 2 cube plus so on up to n cube, right? So the sum of this is going to be n square into n plus 1 whole square divided by 4. So this will be the limit of, this is going to be n square into n plus 1 the whole square divided by 4, and x square, the value of x is n square, right? So x square is going to be n raised to 4, okay, as n tends to infinity. So this is equal to n square, and 2 n out of these will get cancelled out. I'll get the limit of, okay, 1 by 4 I'll take out. I'll get n plus 1 divided by n whole square, okay, as n tends to infinity. So this is going to be 1 by 4 times the limit of, if I split it, it is going to be 1 plus 1 by n the whole square as n tends to infinity. So this is 0, this is 1, so it is going to be 1 by 4. So the answer is going to be 1 by 4, which is the option 2. Okay, I hope I have covered almost all the concepts which are going to appear from this chapter. Okay, I also request that you solve more and more problems, because as far as the calculus is concerned, I mean, we started from limits today, and we have also done continuity. Tomorrow we are going to do the differentiability and differentiation. So if you look at these things, then the topics are too vast, and the number of problems are quite enormous. So you cannot really touch every problem before the exam. There cannot be something called 100% preparations for this. But one thing here is that for these problems you can solve quite a lot of time and put it into the other chapters during the exam. So I strongly suggest that you practice the problems on limits, starting from limits, continuity, differentiability, the differentiation, application of the derivatives, integration, application of the integrals and differential equation. So on these topics, if you spend good amount of time, then it is going to cover almost 30 to 40%, or maybe even more than that of your KCET. Okay, so I request that you go through these very carefully. And today, in today's class, we have done the problems, I mean the previous year questions from 2023 until 2019, if I'm not wrong. So I request that you take up the problems even before 2018 and try to solve. Okay, so let us meet in the next lecture with the topic differentiability and differentiation. Okay, thank you.